Introduction. Beyond time. What if time doesn't flow the way we feel it does? What if the past, the present, and the future all exist at once, woven into a silent, timeless structure far beyond our perception? Greene, one of the most influential physicists and science communicators of our era, invites us to explore these questions with open minds and steady hearts. His vision stretches beyond equations and theories. It is a search for meaning. Nestled deep within the fabric of the cosmos, in this audiobook, we'll travel through the nature of time, the possibility of parallel worlds, the rise and fall of entropy, and the place of consciousness in a universe destined to fade. Guided by Greene's profound insights, we will slow down, not just to understand the universe, but to feel its quiet immensity. This is not a journey of speed, but depth, a chance to listen, reflect, and gently drift through some of the most beautiful and mysterious questions science can offer. Chapter 1. The Illusion of Time. Time feels so simple. It ticks forward, second by second. It carries us from memory to moment to mystery. We live within it, measure it, chase it, and fear it. Yet, according to Greene and to the physics he studies so deeply, our experience of time may be one of the greatest illusions of all. We speak of time as a river, flowing steadily from past to future. But the laws of physics don't require this flow. In fact, they suggest something far stranger, that time may not flow at all. In the world of Einstein's relativity, time and space are not separate things. They are fused into a single entity, spacetime. And in this spacetime, what we perceive as past, present, and future are simply coordinates. Just as different locations exist in space simultaneously, different moments may exist in time simultaneously as well. This idea leads to what physicists call the block universe. In a block universe, all moments past, present, and future exist at once, like frames in a film strip. We feel time moving forward, but the universe, in a sense, does not. Greene compares this to reading a novel. As readers, we move through the story one word at a time. But the book itself, the whole story, already written, already present. Our experience is linear, but the structure is complete. Why then do we feel time passing? Part of the answer lies in the nature of memory. Our brains are built to store the past, but not the future. We remember what has happened. We imagine what could come. This asymmetry gives us the sensation of motion through time. But that sensation may be tied more to biology than to the nature of time itself. Another piece of the puzzle comes from entropy, the measure of disorder in a system. As entropy increases, melting, smoke dispersing, stars burning, out we see a clear direction to time forward. Yet the fundamental laws of physics are time-symmetric. They work the same whether time moves forward or backward. So, where does the arrow of time come from? Greene explains that it's not time itself that's flowing, it's entropy that's increasing. And our awareness of that increase is what gives rise to the sense of time moving forward. This leads to a haunting implication. If the laws of physics don't prefer one direction of time over another, then time's direction may be an emergent feature, something that arises from the universe's initial conditions, rather than something built into its core. Greene often reflects on how unsettling this can feel. If the future already exists, just as the past does, then are we truly free? Do we make choices, or do we simply experience them? Are we carving new paths or walking along tracks already laid? And yet, he doesn't fall into despair. Instead, he finds beauty in this strangeness. The universe, in all its silence and stillness, holds a deeper rhythm, one we are just beginning to hear. The illusion of time's flow may be a trick of perception, a result of how our minds evolved. But even so, it's a powerful one, shaping how we live, how we love, how we hope. In the end, perhaps the illusion is not a flaw in our understanding, but a gift, one that allows us to experience meaning, narrative, and wonder within a cosmos that may not move at all. In the next chapter, we'll explore how this still structure, the spacetime block, came to be seen not as a metaphor, but as a measurable scientific reality. We'll step into the geometry of the cosmos itself. Chapter 2: Spacetime and the Fabric of Reality in the Early Days of Science. Space and time were thought to be separate realms, distinct stages on which the drama of the universe played out. Space was where things were. Time was when they happened. But in the 20th century, this comfortable view was shattered. Enter Albert Einstein with the theory of special relativity. Einstein revealed that time is not absolute. It does not tick the same for everyone. Instead, it can stretch or shrink depending on how fast you move. This was more than a technical insight, it was a revelation. Time, once thought rigid, was now flexible, elastic, and deeply connected to motion. But Einstein didn't stop there. A few years later, with his general theory of relativity, he went further. Space and time weren't just linked, they were the same thing. Together, they formed a dynamic fabric called spacetime, a four-dimensional arena in which the universe unfolds. Greene describes this fabric not as an abstract concept, but as something real, tangible in the mathematical sense. Spacetime can curve, it can ripple, it can be stretched by expanding galaxies or warped by the presence of mass and energy. Just as a trampoline dips under the weight of a bowling ball, space-time bends around stars, planets, and black holes. And this curvature is not just a passive effect, it creates what we perceive as gravity. When a planet orbits a star, it is not being pulled by an invisible force as Newton once imagined. Instead, it is following a natural path through curved space-time, a geodesic, the straightest possible line in a bent world. This vision changed everything. No longer were space and time mere backgrounds. They became actors in the cosmic story, shaping the motion of galaxies and the structure of the universe itself. But what does this mean for us? For one, it means that space and time are interchangeable in some sense. Move fast enough through space, and time slows down for you. Get close enough to a massive object, and time bends along with space. This isn't speculation, it's been measured. GPS satellites must correct for these effects daily, or their clocks would drift out of sync with Earth. Greene often reflects on the poetic beauty of this reality. Space-time isn't just a concept in a textbook. It's a living structure woven into everything we see and touch. And we, in turn, are part of it, not separate from the universe, but embedded within its very geometry. This leads to a striking conclusion. Events do not simply happen in time. They are laid out in space. That means the past and the future are not gone or unborn. They are simply elsewhere in the block. We experience one slice at a time, like scanning through a sculpture with a thin beam of light. But the sculpture itself, the full shape of reality, already exists. It's difficult to grasp because we're wired to live moment to moment. Our brains build reality as a sequence of now. But physics invites us to see a deeper structure, one where now is relative, and where time is part of the shape of the universe, not something apart from it. So, the next time you look up at the stars, remember, you're not just gazing into space. You're looking into a warped, rippling fabric of space-time structure that holds not just objects, but entire moments. A silent geometry that connects everything in the next chapter. We'll step into one of Greene's most famous contributions, the theory of string vibrations that may underlie everything we see. A deeper level beneath space-time itself. Chapter 3. The Elegant Universe. The deeper we peer into the workings of the cosmos, the more layers we uncover. Galaxies give way to stars, stars to atoms, atoms to quarks, and then, beyond even these smallest known particles, Some physicists believe there is something else, something smaller, something vibrating. This is the realm of string theory. One of the boldest and most ambitious ideas in modern physics, and one of the central topics of Brian Greene's work. At its heart, string theory suggests that what we call particles, electrons, quarks, photons, not point-like dots, but rather tiny, vibrating loops of energy. Each type of vibration gives rise to a different particle. Much like a violin string can produce multiple notes depending on how it's played, a fundamental string can become an electron, a neutron, or a graviton, depending on how it moves. In this vision, all of reality is music, strings vibrating in a cosmic symphony, producing the particles, forces, and fields that make up the universe. Greene calls this the elegant universe, a place where the seeming chaos of nature is governed by harmonious, mathematical rhythms. But this harmony comes at a cost, extra dimensions. For the mathematics of string theory to work, it requires more than the familiar 3 dimensions of space and 1 of time. It demands 10 or even 11. Where are they? According to the theory, these extra dimensions are compactified, curled up so tightly that they are hidden from view, like threads woven into the fabric of reality, too small to detect. Greene explains these hidden dimensions using metaphors. Imagine an ant walking on a garden hose. From a distance, the hose looks one-dimensional, but up close, the ant can move not only forward and backward, but also around the hose. That circular path is a hidden dimension, real but subtle. These extra dimensions, according to string theory, determine the way strings vibrate. In this sense, the shape of the hidden dimensions is like the architecture of the universe itself. It's a daring idea, and one that so far remains unproven. Critics point out that string theory is mathematically rich, but experimentally elusive. No direct evidence has yet confirmed its predictions. Still, many physicists, including Greene, are drawn to its beauty, consistency, and potential to unify everything. Quantum mechanics, gravity, electromagnetism, and the nuclear forces. It may be the long-sought theory of everything, a single framework that explains all of nature. From the dance of subatomic particles to the motion of galaxies. But string theory is more than just equations. It reshapes our understanding of what is real. If strings are the foundation of all things, then reality itself is made of motion, of rhythm, of silent, unseen waves rippling through multi-dimensional space. Greene finds wonder in this view. For him, the elegance of the universe is not just aesthetic, it's meaningful. It shows that beneath the surface of everyday experience lies a hidden order, a unity that connects all things, and in that unity, he sees not only science, but art, a reminder that the universe is not a machine of cold, random events, but a masterpiece, intricate and interwoven, waiting to be heard by those who know how to listen. In the next chapter, we will drift even deeper into this multiverse of ideas, into the radical possibility that our universe may be just one of many. Chapter 4: Parallel Worlds and Infinite Possibilities. What if the universe we see, stars, galaxies, and the fabric of space-time itself is only one version of reality, one slice of a much larger whole? In Brian Greene's exploration of the cosmos, this question opens the door to one of the most mind-bending possibilities in modern physics: the multiverse. The idea is simple, yet staggering. There may not be just one universe. There may be many, perhaps infinitely many, each with its own version of space, time, matter, and even physical laws. But how could this be? One version of the multiverse arises naturally from cosmic inflation theory that describes how the universe expanded rapidly after the Big Bang. According to this model, some regions of space continue inflating, creating bubble universes that pinch off and form their own realities. Ours is just one bubble in a vast cosmic foam. Another version stems from quantum mechanics, the strange and probabilistic framework that governs the subatomic world. In the many worlds interpretation, every quantum event creates a branching path. Every decision, every outcome splits reality into new versions. You turn left, another you turns right. All possibilities happened not in the same world. In this view, the multiverse isn't out there, it's also in here, branching from every moment. And then there's string theory, which doesn't offer just one solution to the laws of physics, but a vast landscape of possible solutions, 10,500 different universes, each with its own unique parameters, shaped by the geometry of extra dimensions. Greene approaches these ideas with caution and wonder. He doesn't claim that all multiverse theories are true, but he reminds us that our universe may not be the only possible arrangement of nature. The implications are profound. If the multiverse is real, then everything that can happen does happen. Somewhere in one world, Earth never formed. In another, civilizations thrive among the stars. In yet another, you're living a life slightly, perhaps vastly different from this one. This can be dizzying. It may feel like we're just one speck in an ocean of versions. But Greene finds comfort here, too, instead of making us feel small. The multiverse can deepen our sense of connection. We are not just observers of one reality, we are part of a larger tapestry, a pattern playing out across infinite branches. It also shifts how we think about meaning and possibility. If the future isn't fixed, if reality contains multitudes, then choice, imagination, and even chance become fundamental parts of the cosmos. Of course, these ideas remain speculative. No telescope has glimpsed another universe. No experiment has confirmed these parallel realities. But physics, especially at its frontier, often begins with bold imagination, ideas that seem impossible, until one day they're not. Whether the multiverse exists or not, pondering its possibility stretches the limits of the human mind. And in that stretching, we discover something essential, not just about the universe, but about ourselves, our thirst to understand, to question, to look beyond what is, and ask, what else might be in the next chapter? We'll turn our gaze back to war, something more grounded and yet equally profound. The hidden force shaping the future of all things. The quiet, relentless rise of entropy. Chapter 5. Entropy, Order, and the march toward death in the vast and intricate dance of the cosmos. One force stands out as both subtle and unstoppable. Entropy. Entropy is often described as the measure of disorder in a system. But it is more than that. It is the engine that drives the arrow of time. The reason why time seems to flow in one direction. Greene paints entropy not just as a physical principle, but as a cosmic narrative one that shapes the fate of everything from stars to galaxies, from life itself to the universe's eventual end. To understand entropy, imagine a child's carefully built sandcastle on the shore. The castle is ordered, structured, and fragile. Over time, waves wash over it, scattering the grains. The sand spreads out, disorder increases, and the castle disappears. This process from order to disorder's entropy in action in physics. The second law of thermodynamics states that the total entropy of an isolated system can never decrease. It can stay the same or it can increase, but it never goes backward. Why does this matter for time? Because entropy's increase gives time a direction. It tells us which way is past and which way is future. We don't see sand spontaneously reassemble into castles. This asymmetry explains the familiar flow of time from morning to night, from youth to age, from birth to death. But at the fundamental level, the laws of physics are time-symmetric. They work the same if time ran backward. This paradox puzzled scientists for centuries. Greene highlights that the key lies in the initial conditions of the universe. At the moment of the Big Bang, the universe started in a state of extraordinarily low entropy highly ordered. Since then, entropy has been increasing ever since, setting the arrow of time in motion. As entropy rises, the universe moves toward what physicists call heat death state, where energy is evenly spread. It's a future that seems bleak. Stars burn out, galaxies drift apart, and the cosmos becomes a cold, dark expanse. Yet Greene doesn't see this as mere doom. He views entropy's march as a canvas on which life, complexity, and consciousness emerge. Life is an oasis of order in a desert of disorder. It uses energy to build structures, maintain organization, and create meaning even as the universe itself tends toward chaos. Our very existence is a temporary, luminous spark against entropy's tide. This perspective brings both humility and awe. We are part of a vast process, fleeting and fragile, yet profoundly significant. Entropy links us to the cosmos not just through physics, but through the stories we tell, the narratives of growth, decay, and renewal. In this light, time is more than a measurement. It is the unfolding of a grand drama played out on the stage of entropy. In the next chapter, we will delve into the cosmic origins, the birth of the universe itself, and explore what Brian Greene reveals about time before time began. Chapter 6. The Origin of Everything. The story of time inevitably leads us back to its beginning, the moment the universe burst into existence. Brian Greene invites us to ponder a question both simple and profound. What does it mean for the universe to have a beginning? And what was time like before that? According to the Big Bang Theory, around 13.8 billion years ago, the universe expanded from a state of unimaginable density and heat. Space and time themselves emerged in this event, stretching out into the vast cosmos we inhabit today. But what came before? This question troubles physicists and philosophers alike. Traditional notions of before lose meaning if time itself began with the Big Bang. Greene explores ideas from quantum cosmology, where the beginning is not a singular, sharply defined moment, but a fuzzy, probabilistic event. Time may have no edge, but rather a smooth boundary where classical concepts break down. One such proposal is the Hartle-Hawking state, named after physicists James Hartle and Stephen Hawking. It imagines the universe as a kind of sphere in time without a beginning or end, where time becomes more like a spatial dimension near the origin. In this view, asking what happened before the Big Bang is like asking what is north of the North Pole, an ill-posed question. These ideas challenge our everyday experience of cause and effect. forcing us to rethink what it means for something to start. Greene shows how modern physics blends the mysterious with the mathematical, crafting models that expand our minds even as they elude intuition. He also reflects on the poetic beauty of this cosmic birth, spontaneous blossoming of space, time, and matter from the quantum vacuum. From this beginning, the universe evolved, cooling, forming particles, atoms, stars, galaxies, and eventually giving rise to life and consciousness. Understanding the origin is more than academic. Connects us to the cosmos as participants in an unfolding story in the coming chapters. We will explore how life fits into this vast picture and how the mind itself may be entwined with the fabric of time. Chapter 7: The Human Mind in a Cosmic Context. As we gaze into the vastness of the cosmos, it is natural to wonder about our place within it. Greene invites us to consider not only the physical universe, but also the intricate relationship between the cosmos and the human mind. The mind is an extraordinary phenomena capable of reflecting on itself, imagining distant galaxies, and pondering the nature of time. This capacity for self-awareness sets us apart in the universe, but it also connects us deeply to the cosmos at its core. The brain is a product of the physical universe, shaped by the laws of physics and chemistry. Neurons fire in intricate patterns, giving rise to thought, memory, and consciousness. Yet, consciousness itself remains one of the greatest mysteries in science. Greene explores how our understanding of the mind intersects with the fabric of spacetime. Our perception of time, its flow, direction, and passages, not just a cosmic truth, but also a feature of how our minds process experience. Memory plays a central role here. Our brains record past events, building a narrative of self and history. This narrative is essential to our sense of identity and continuity. Yet this narrative is also construct a way our minds impose order on the raw flow of events. It shapes our experience of time, making it feel linear and purposeful. Greene also touches on the concept of time perception in neuroscience. Experiments show that the brain can alter its sense of time based on attention, emotion, and even certain drugs. This flexibility reveals that time, as we experience it, is a delicate interplay between external reality and internal cognition. Furthermore, the human mind has the remarkable ability to imagine alternative futures and pasts. We simulate scenarios, anticipate outcomes, and plan accordingly. This mental time travel extends our existence beyond the present moment. But what does this mean for our place in the universe? Greene suggests that our minds are not separate observers, but active, participants in the cosmic story. Through consciousness, the universe becomes aware of itself. This perspective evokes a profound sense of connection. The atoms in our bodies were forged in ancient stars. Our thoughts unfold within the fabric of spacetime. We are both products and explorers of the cosmos. Yet this realization also brings humility. The universe is vast and indifferent, and our time here is fleeting. But within that fleetingness lies beauty, the chance to reflect, to wonder, and to seek meaning. In this chapter, Greene invites us to embrace this duality, the fragility of human life set against the grandeur of the cosmos. Our minds, though limited, hold the capacity for infinite curiosity. And through that curiosity, we continue the age-old quest to understand time, space, and ourselves. In the next chapter, we will examine how time itself might come to an end, concept that challenges our deepest assumptions about reality and existence. Chapter 8: The End of Time. The idea that time might come to an end is as unsettling as it is fascinating. Greene confronts this concept with both scientific rigor and philosophical depth, challenging us to reconsider what time truly is and what its ultimate fate might be. From the beginning of the universe, time has been a constant companion, marching steadily forward. Yet physics suggests that this march may not be eternal. One possible ending comes with the heat death of the universe, a state where entropy reaches its maximum, and no usable energy remains to drive change or processes. In such a universe, all motion ceases, stars burn out, and the cosmos becomes a cold, dark expanse. If time is tied to change and processes, what happens when change stops? Greene points out that time, as we understand it, may lose meaning without events to mark its passage. In a universe frozen in entropy, the flow of time could effectively halt. Another scenario comes from the possibility of a big cruncha, reversal of the universe's expansion that would collapse everything back to a singular point, potentially resetting the cosmic clock. There are also speculative ideas about the quantum nature of time, where the fabric of space-time itself might dissolve or transform, blurring the distinction between past, present, and future. These endings raise profound questions. Does time have an absolute existence, or is it emergent a feature of a dynamic universe rather than a fundamental backdrop? Greene explores how modern physics wrestles with these dilemmas, revealing that time may be more fragile and complex than our everyday experience suggests. Yet, within these uncertainties, there is a profound poetic beauty. The finite nature of time imbues our lives and the universe with meaning, urgency, and wonder. To know that time might end is to recognize the preciousness of each moment. The fleeting dance of existence in a cosmos that is both eternal and ephemeral. In contemplating the end of time, Greene invites us to embrace the mystery, to find solace in our brief but brilliant place within the vast tapestry of spacetime. In the next chapter, we will explore how science and faith navigate the search for meaning in a universe governed by physical laws. Chapter 9: Faith, Meaning, and Science. The quest to understand the universe often leads us beyond the realms of equations and experiments, into questions that touch the heart of human experience, meaning, purpose, and belief. Brian Greene approaches these themes with humility and openness, recognizing that science, while powerful, does not always answer the deepest questions alone. Science reveals the workings of the cosmos, the dance of particles, the flow of time, the birth and death of stars. But it does not prescribe how we should live or what our lives ultimately mean. Faith and spirituality have long sought to fill this gap, offering narratives that connect us to something larger beyond ourselves. Greene does not dismiss these perspectives. Rather, he sees science and faith as different ways of engaging with mystery. He suggests that science can inspire awe and wonder, creating a sense of meaning rooted in the grandeur and intricacy of the universe. Yet, he also acknowledges that many find comfort and guidance in spiritual beliefs that provide moral frameworks and community. This balance invites reflection. How do we reconcile a universe governed by physical laws with our desire for meaning? For Greene, the answer lies not in conflict, but in conversation, a dialogue between the empirical and the existential. The universe's vastness and complexity can evoke both humility and inspiration. We are small, fleeting, and yet capable of profound insight and creativity. Science expands our horizons, revealing the beauty and strangeness of reality. Faith offers stories and rituals that nurture the human spirit. Together, they enrich our understanding of what it means to be alive. In a cosmos that is both indifferent and deeply mysterious. In this chapter, Greene encourages us to embrace uncertainty and to find our own paths to meaning, whether through science, spirituality, or a blend of both. As we move to the final chapter, we will consider what it means to live in a universe where time itself is temporary and how that awareness shapes our existence. Chapter 10: Living in a Temporary Universe. To live is to exist within time, a fleeting, ever-moving river that carries us from birth to death, from moment to moment. Yet, Brian Greene's exploration reveals a humbling truth. The universe itself, the grand stage on which all existence unfolds is temporary. It too will one day fade into silence. This realization shapes the way we understand ourselves and our place in the cosmos. The universe began approximately 13.8 billion years ago, blossoming from the Big Bang, a singular event that gave birth to space, time, and matter. Since then, it has been expanding, evolving, and aging. But like all things that arise, it will also decline, according to our current understanding. Entropy, the gradual increase of disorder, will eventually lead to the so-called heat death. In this distant future, stars will burn out, galaxies will drift apart, and the universe will become a cold, dark expanse, devoid of energy gradients that make life and change possible. What does this mean for us who live within its bounds? Greene suggests that this finitude does not diminish the value of life or the cosmos. Rather, it gives our existence urgency and meaning. When something is temporary, every moment becomes precious. Our awareness of the impermanence of the universe parallels our awareness of our own mortality, tying together the microcosm of human life and the macrocosm of cosmic history. Greene encourages us to embrace this perspective, not with despair, but with a sense of wonder and responsibility. We are participants in a rare and beautiful moment, witnesses to a universe in its vibrant youth. Our actions, choices, and creations, though brief, resonate within this vast temporal landscape. Furthermore, Greene reflects on how the temporary nature of the cosmos inspires us to seek knowledge, to create art, to connect with others, and to explore meaning beyond the confines of time. This awareness can deepen our appreciation for the present and motivate us to live fully in this light. Time's impermanence becomes a source of profound inspiration, a call to cherish life and the mysteries of existence. As we conclude this journey through Greene's vision of the universe and time, we are reminded that while the cosmos may be temporary, the questions it raises and the wonder it inspires are timeless. Final reflections beyond time. As we arrive at the conclusion of this journey through the profound and intricate landscape of time and the universe, guided by the wisdom of Greene, it is fitting to pause and reflect deeply on the path we have traveled together. Time, that ever-present companion of human experience, has proven far more elusive and complex than our everyday intuition suggests. Once perceived as a simple, steady flow, invisible river carrying us from past to future time, now appears as a multi-layered phenomenon, entwined intimately with space, consciousness, and the very essence of reality. Throughout this exploration, we have seen how modern physics dismantles the comforting illusions we carry about time. The flow of time, so fundamental to our sense of self, may be a construct of the mind, an emergent property arising from the complex interplay of entropy and memory. We have delved into the fabric of spacetime, understanding it as a dynamic, four-dimensional tapestry, flexible and malleable, where the presence of mass and energy bends the very geometry of reality, creating the phenomenon we perceive as gravity. We venture deeper into the elegant realm of string theory, where the fundamental constituents of existence are not point particles, but vibrating strings orchestrating a cosmic symphony across hidden dimensions beyond our direct perception. This vision of an elegant universe reveals a harmony and unity beneath the apparent chaos of the cosmos. The mind-bending possibilities of parallel worlds and the multiverse challenged our understanding and destiny, inviting us to consider a reality far vaster and more diverse than the one we observe. The relentless increase of entropy emerged as the arrow that shapes the direction of time, linking the grand cosmic story to the fleeting moments of life and consciousness. We have contemplated the very origin of time and the universe, events where classical concepts blur and quantum uncertainty reigns, pushing us to rethink beginnings, causality, and the nature of existence itself. The human mind, fragile yet extraordinary, finds itself deeply embedded in this cosmic tapestry, capable of reflection, imagination, and wonder. Through our awareness, the universe attains a degree of self-understanding, a cosmic consciousness that connects us all. Yet, despite this grandeur, the universe remains temporary. Its eventual end, whether through heat death, a cosmic collapse, or unknown quantum transformations, reminds us of the fragility and impermanence that define all things. But in this impermanence lies profound meaning. The finite span of the cosmos and of our lives imbues each moment with urgency and preciousness. It compels us to seek knowledge, create, love, and find purpose within the vast silence. Science and faith, often seen as opposites, can harmonize in this search, enriching our experience of wonder and connection. Brian Greene's vision is not merely a collection of scientific theories. It is an invitation to embrace mystery with humility and curiosity, to dwell in the questions as much as the answers, to find awe in the unknown. This journey beyond time is also a journey inward toward deeper understanding of ourselves, our place in the universe, and the fleeting but beautiful nature of existence. May these reflections inspire you to look upward and inward with equal passion, to cherish the moments you have, and the mysteries yet to unravel. Thank you for joining this voyage into the heart of time and reality. May your own journey continue with wonder, courage, and grace.